Today, our topic is transistor biasing. So before going to that, I would like to recapitulate what we discussed in the previous class. So previous class, we talked about basics of transistors and then transistor configurations. So what are the transistor basics? Transistor is a three-terminal semiconductor device which consists of two junctions and three layers. So namely emitter, base and collectors. These are the terminals. Junctions are emitter base junction and collector base junction. So emitter base junction is always forward bias. Base collector junction is always reverse bias. Based on different combinations, we will use different modes of transistor operations. One is active region, cutoff region, and saturation region also. So coming to the transistor configurations, so these are three types. One is common base configuration, common emitter configuration, and common collector configurations. So common base configuration is nothing but base is common to both input and output. We call it as common base configuration. Similarly, common emitter configuration. So the emitter terminal is common to both input as well as output. We call it as common emitter configurations. So in common base, common emitter and common collector, we also call it as a grounded base configuration or grounded emitter configuration or grounded collector configurations. Okay, that means terminal base or emitter or collector terminals are grounded because input and output is common to the terminal, respective terminal. Okay, so today we will see transistor biasing. So first of all, what do you mean by biasing? Biasing means adding some voltage or battery to the circuit for maintenance of output voltage. We call it as transistor biasing. See, you will see the circuit. It is a transistor. First, this one is the input AC signal. This one is the RB means base resistance. So this is the terminal. This one is emitter, base, and collector terminal. Okay, this is the resistance, load resistance. So across load resistance, we find the output voltage. Okay, for example, I am given input voltage. So this is the input voltage, sinusoidal input voltage. We are given to here. So what happened? Already we know that emitter base junction is forward bias, base collector junction is reverse bias. Already we know that. So whenever signal or input signal is applied to a transistor, so first junction, emitter base junction is forward bias means first half cycle. So this is the first half cycle. That means positive portion is amplified. You will see this is the very less magnitude. For example, this is 1 volt. Now after applying to transistor this signal is amplified. The signal is amplified. So positive portion is amplified from 1 volt to approximately 2 volts. Consider 2 volts. That means positive half is amplified by using transistor. What about negative portion? This is the negative portion. In second junction, that is base collector junction, is reverse bias. So reverse bias means transistor is off. That means there is no amplification. See, whatever the voltage is there in the input side, same voltage will appear at the output because there is no amplification. Okay. So for that reason, we go for biasing. So we want, this is the unfaithful amplification because only one half cycle is amplified. So negative portion of the cycle is not amplified. So this amplification, we call it as a unfaithful amplification. For faithful amplification, we go for biasing. So biasing is nothing but adding some voltages or resistance to get the amplified output. Okay, this is the meaning of biasing. See, transistor biasing means providing a fixed or minimum amount of current which would flow through the transistor with a desired fixed voltage across the transistor junctions. So the proper value of these currents and voltages allow a transistor to work in a linear region and it amplify the weak signal faithfully. Faithfully is nothing but it amplified both portion, positive portion and negative portion. Okay. So why we need biasing? DC biasing means if a signal of very small voltage is given to the input of BJT. What do you mean by BJT? BJT means bipolar junction transistor. So when small signal, so this is the transistor symbol, a small voltage is given to the input of BJT. Here this is the input of BJT. It cannot be amplified because the BJT, to amplify the signal, it meets two conditions. One is input voltage exceeds the cut-in voltage. So for example, it is a silicon transistor. So what is the cut-in voltage? Cut-in voltage VCE cut-in means 0.6 volts. So after that only transistor is on. So the input voltage should exceed the cut-in voltage for transistor to be on. So what is the second criteria? The BJT means bipolar junction transistors should be in active region to be operated as amplifier. What do you mean by active region? So active region means current is steady state. So this is the linear region. So this is the steady state current. So this region we call it as active region. Steady state region we call it as active region. Okay. So first we will define the operating point of a transistor. So whenever we are seeing a transistor, what is the output in common emitter configuration? Output means IC, VCE, comma IC. So this is called operating point. Collector emitter voltage, comma collector current. This is called operating point. We have to maintain the collector emitter voltage at a proper level by using battery voltage. So a transistor, a steady state of operation depends on a great deal on its base collector, base current, comma collector voltage and collector current. Therefore, if transistor is to be operated as a linear amplifier, it must be properly biased to have a suitable operating point. So establishing a correct operating point means VCE, IC, requires the proper selection of bias resistors and load resistors to provide the appropriate input current and collector voltage conditions. So when this operating point we will get based on Proper bias resistors means RB. Just now we seen this one, proper bias resistors and proper load resistors. We will get this point. So this is E means VCE comma IC at output side. So the correct biasing point for a bipolar transistor, either NPN or PNP, generally lies somewhere between two extreme operations with respect to the fully on or fully off along its load line. So this central point, we call it as quotient point or Q point or operating point. So these are the three different names. So quotient point or Q point or operating point. So for example, so this is the transistor configurations means this is the VCE, this one is IC. So in middle, we want to select the operating point at the middle of the active region only. That is called operating point. Operating point or quotient point or Q point. In short, Q point. Okay. Factors affecting the operating point. What do you mean by operating point? Operating point is nothing but VCE comma IC. This is called operating point. That means collector emitter voltage comma collector current. So many factors these operating point will affect. So the main factor that will affect the operating point is temperature. Okay. So the operating point shifts due to change in temperature. We know that if temperature increases, the charge carrier acquires thermal energy and uh, acquire thermal energy and move towards the junction. It constitutes the current. So as temperature increases, the values of collector emitter current, beta means amplification factor, VBE means base emitter voltage get affected. So ICB0 means reverse leakage current. So that leakage current gets doubled for every 10 degrees centigrade rise in temperature. And also base emitter voltage decreases by 2.5 millivolts for every 1 degree centigrade rise in temperature. So the main problem which affects the operating point is temperature. So the main problem is temperature. Due to temperature, the operating point may differ. So hence operating point should be made independent of temperature. So as to achieve the stability. To achieve this, biasing circuits are introduced. So why we go for biasing? Biasing is nothing but adding some battery voltage is called as biasing, adding some voltage. Why we are adding? Due to temperature, some parameters like collector, emitter, current, amplification factor, base emitter voltage, these are differ or variable. If these parameters are varied, so operating point is also varied. So to reduce these effects, we will introduce the criteria, we call it as biasing. Okay. So in biasing, I would like to define the DC load line as well as AC load line. So what do you mean by DC load line? DC load line is nothing but whenever no AC signal is applied to a transistor, then we will calculate the output. We call it as DC load line. So DC load line is the locus of IC and VCE and BJT remains in the active region. So it represents all the possible combination of IC and VCE for a given amplifier. So you will clearly understand Next slide, because I'm explaining in graph. So procedure to draw the DC load line. So how to draw the DC load line in the output side versus VCE, comma IC. So to draw the DC load line of a transistor, we need to find the saturation current. Saturation current is nothing but IC. Cutoff voltage means VCC. The saturation current is the maximum possible current through the transistor and occurs at a point where the voltage, the collector, is minimum. So the cutoff voltage of a maximum possible voltage across the collector and occurs at a zero collector voltage. So you will clearly understand in this graph. See, this one is the transistor. So this one is the transistor. So emitter, base, collector. So this is RB means base resistance, collector resistance. So what do you mean by VBB? So this is the biasing voltage. VBB means battery biasing voltage. So what do you mean by VCE? VCE is nothing but collector emitter voltage across this terminal. So this is the collector terminal, this is the emitter terminal. So this is VCC. Okay. So what is the output of this circuit means? This is the output of this circuit. Already we studied this one in a common emitter configuration, same graph. So in this, you will observe how to get this graph. So this is called in common emitter, two characteristics, input characteristics and output characteristics. So this one is the output characteristics because we are taken the graph versus VCE, comma IC. That means it is the output characteristics. How to get this curve means, so we have to fix the IB value for different values and varying VCE, and we will note down the IC value. So first IB is equal to 0 milliamperes. First we will fix the constant. Then, so this one is the VCE. This one is the VCE. IB is equal to 0. We will varying the VC value. We will varying the VC value. IC corresponding IC value is linearly increases from this point. Then it is constant. After that, what we do? IB is equal to 0.1 milliamperes. We have to put IB is equal to 0.1 milliamperes. Then varying VC. VC means collector emitter voltage is varying. By varying the collector emitter voltage, corresponding IC value is increases, and after some up to this point is a linear. VC is increases, IC is also increases up to this point. Then it will be flat, means it is a constant. Similarly, we are taken different IB values and varying VCE, we will get IC. So this is called output characteristics. So how to draw this DC load line across VCE versus IC means, see, we will see here. So by applying the KVL to the output circuit, so this is similar to, this is the output circuit. See, output circuit means this is the VCC, RC, and this one, okay, VCC, RC. So this is the across terminal voltage. So by we know that KVL means this is the VCC. What is the KVL? VCC minus, next first one is the VCC minus IC RC minus VCE is equal to 0. VCC minus ICRC minus VC. That means all the terms. This is the voltage, this is the voltage, this is the voltage. That is called KVL. So VCC minus ICRC minus VC is equal to 0. So from that, VCC is equal to ICRC. This one is ICRC plus VCE. So from this equation, what do you mean by VCE? VCE is equal to, so VCC minus ICRC. Okay. So when IC is equal to 0 in this equation, means collector current is equal to 0, means this whole term is equal to 0. So VCE is equal to VCC. VC is equal to VCC. That means collector current is equal to 0. So collector emitter voltage is equal to VCC, battery voltage of collector side. So I will explain in this graph. So VCE here, IC is equal to 0 means uh, see, IC is equal to 0 means in this graph. So this is the IC. So IC is equal to 0 means this point. IC is equal to 0 means this point. And VCE is equal to, this one is VCE is equal to VCC. This point in this graph. See, IC is equal to 0, VCE is equal to VCC. So VCE is equal to VCC. Similarly, from this equation, when VCE is equal to 0, so this one is equal to 0 means this one is equal to 0. Collector emitter voltage is equal to 0. What happened? VCC is equal to ICRC. VCC is equal to ICRC. Then IC is equal to VCC by RC. So IC is equal to VCC by RC when VCE is equal to 0. Okay. When VCE, this one is VCE. When VCE is equal to 0, this point, what is IC? IC is equal to VCC by RC. So you can draw the line from A to B. We can draw the line from A to B. This is called DC load line. This is called DC load line. So already we know that below this IB is equal to 0 milliamperes, we call it as cutoff region. This one is saturation region. This area is saturation region, and this one is the active region. So this one is the active region. So flat region we call it as active region. So we will take the, what do you mean by Q? Q means a quotient or Q point or operating point. So we are always taken operating point at the middle of the active region only, because we will get amplified full wave. If we are taken this Q or operating point above the middle, so positive portion is clipped. Similarly, if we are taken this Q point below the middle point, negative portion of the input wave is clipped. So we always preferably taken Q point at the middle of the active region only, at the middle. So this is the middle of the active region only. We have taken Q point. So what do you mean by Q point? Q is nothing but VCE. Q is nothing but VCE comma IC. So this is called a Q point. This is called Q point. So we will take a middle by varying this VCC. We will find out the IC value at the middle. Okay. So this is called DC load line. Okay. So we will see one problem. If IB base current is equal to 0.2 milliamperes, assume beta is equal to 100. We know that beta is the amplification factor. It varies from 20 to 500 in common emitter configurations. So we know that beta is equal to IC by IB. So from this, IC is equal to beta into IB. Beta is equal to 100 and IB is equal to 0.2. So 20 milliamperes. IC is equal to 20 milliamperes. So what do you mean by Q point? Q point is nothing. We want to find VCE comma IC. VCE comma IC. Now we got the IC value here. Now we want to find the VCE value. Now we want to find the VCE value. So from the equation, VCC is equal to ICRC plus VCE. So VCC is equal to VCC minus ICRC. So here assume VCE is equal to 10 volts into IC. IC means 20 milliamperes. Milli means 10 power minus 3 into RC means 200 ohms. RC is the 200 ohms. We have to assume this one. So assume VCC is equal to 10 volts and RC is equal to 200 ohms in that circuit. So finally we will get 10 minus 4 is equal to 6 volts. So this is called VC is equal to 6 volts. So Q point marked as on a Q on the output characteristics. So how to mark? So VC is equal to 6 volts and IC is equal to 20 milliamperes. We have to fix. How to fix? So we go for, remember VC is equal to 6 volts. So for example, VC is equal to 6 volts here. VC is equal to 6 volts here. And what do you mean by IC? IC is equal to 20 milliamperes. We have to put corresponding IC value is equal to 20 milliamperes. For example, this. So this is called as Q point. This is called as Q point. We have to find like this. Okay. So this is called DC load line. We go for AC load line. So whenever AC signal is given as an input to the transistor, now we can find the AC load line. So DC load line drawn when no input AC signal is applied to the circuit. If AC signal is applied to the circuit, then the collector current and the collector emitter voltage is changed. Hence, we obtain the load line, call it as AC load line. See, in previous, so this is the transistor. When no input, when no AC signal, so there is no AC signal is given to the transistor, we have to find the voltage VCE, comma IC. So then we call it as operating point. That line is called as DC load line. Whenever AC signal is applied here, AC signal is applied here. So the collector current IC, here IC, and collector current, this one is the collector current IC, and collector emitter voltage. Collector emitter voltage means CE, VCE, collector emitter voltage is changed. Hence, we obtain the load line called as AC load line. So AC load line can be defined as a line on the output characteristics which gives the value of IC and VCE when AC input signal is applied. Okay, simply you have to remember whenever AC signal input is given, we have to change, input signal is given, so collector current and collector emitter voltage is changed. So that line we call it as AC load line. DC load line means we are not given any AC signal to the transistor. Then we have to find the collector emitter voltage and collector current at the output side. We call it as DC load line. Okay. See, the practical biasing circuit of CE configuration is shown in figure below. So this is the practical CE amplifier. So what is the purpose of amplifier? First means we have to amplify the weak signal or strengthen the weak signal. That is the purpose of amplifier. For example, here we are given small signal like my voice. It is the form of signal. So this signal is amplified. So this is 1 volt, peak to peak 1 volts means this signal is amplified in the large way. That is the purpose of amplifier. Okay. So this is the practical CE amplifier. So here, so this symbol is nothing but AC signal. This symbol is nothing but AC signal. DC signal is nothing but plus minus. We call it as DC signal. Okay. See, what is the DC equivalent circuit? DC equivalent circuit means we have to remove the capacitor. So this is the open circuit for DC. So this is open circuit means this will not occur, and here also not occur. Only we will get DC equivalent means RB, RC and VCE. So this is called the DC equivalent circuit of AC circuit, AC amplifier. How we will get? So DC is the open circuit for DC value. Sorry, capacitor is the open circuit for DC value. Okay, so the same circuit can be redrawn like this. So this is the same circuit. The same circuit can be redrawn like this. Just we are adding the voltage, source voltage. So this is the RB, same value, transistor, and RC value, and load. We are adding load. So this is called DC equivalent circuit of AC CE amplifier. Okay, so we know that capacitor blocks DC and it allows AC. We know that. Okay, so this is the DC equivalent circuit. We will redrawn like this. We are adding source voltage and load resistance here. Okay. So here you can observe DC and AC load lines are there in this figure. See, this is the VCE, this is the IC. At output side, so this is the transistor. So this is the collector terminal means collector current, base terminal means base current, E means emitter current. So left hand side we call it as input, right hand side we call it as output. So output side, what are the parameters? So this terminal emitter junction and collector junction, we call it as VCE voltage. So collector emitter voltage here and collector current. So what is the Q point? Q point is nothing but VCE comma IC. We call it as Q point or quiescent point or operating point. We know that how to draw the DC load line. So this is from B to C. From B to C, this is called as DC load line. How to draw the AC load line? It is similar to DC load line, but only thing is we are applying AC signal at the input and variable collector current and variable collector emitter voltage. So this is called as AC load line. So this is called as AC load line. So the intersection of DC load line and AC load line, we call it as Q. Intersection of DC load line and AC load line, we call it as Q. Q means, what do you mean? Q means Q point. This one is Q point or operating point or quiescent point. So this is Q point. So this Q point is always or preferably taken at the middle of the active region only. This is called Q point. So intersection of AC load line and DC load line, that point we call it as Q point or quiescent point. What do you mean by Q? So this is the x-axis, this is the y-axis. So x-axis is VCE. So VCE comma ICQ. Here Q point means VCE Q comma ICQ is called as Q point. Okay. So in this class, let us briefly summarize what we discussed in this class. In this class, we are talking about transistor biasing. Why we go for biasing, first of all. So biasing means we have to maintain the output voltage for a certain level. For example, if AC signal is given to an amplifier, so transistor first junction is forward bias and second junction is reverse bias. We know that. Whenever the signal AC signal is applied to a transistor, first half is the positive, that is amplified because first junction is forward bias. So the second half or negative half is not amplified because of negative or reverse bias. For that reason, we have to maintain the collector current at the output side as well as collector emitter voltage at the output side. For that reason, we have to maintain some voltages by using biasing. So biasing means we have to add the voltages and resistance and load resistance, so that we have to maintain the VCE comma IC. So that is called biasing. So biasing affects some parameters. First one is the temperature. Because of temperature, so base emitter voltage is changed, amplification factor is changed, and IC value is also changed. So to overcome this temperature problem, we have to maintain the IC or collector current and collector emitter voltage. We go for biasing for better amplification. So in biasing, two things are there. One is DC load line and AC load line. So what do you mean by DC load line? Whenever no AC signal is applied to the input of amplifier, at that time we call it uh, input signal. AC input signal is not given to the amplifier. We call it as DC load line versus VCE comma IC. And similarly, what do you mean by AC load line? Whenever AC signal is given to the AC signal is given to the circuit, then we will calculate the VCE comma IC. We call it as DC load line. Then intersection of AC and DC load line, we call it as Q point. So Q point is always taken at the middle of the active region only, so that we can amplify the signal in better way. Okay. Okay, thank you.